Now, basically, the process of cremation, if you think of the human body as being basically mostly comprised of water, the best way to describe the process of cremation would be rapid oxidization of the human body by exposure to heat or flame. So we're not actually burning anything. The first stage of cremation is dehydration. Okay? We have to burn off all the water, okay, by evaporation, which is a cleaner part of the cremation, because water just produces steam, which doesn't pose a problem. The fats and other body solids are the only part that's really combusted in cremation. What remains is fine bone fragments, which are very brittle because you've removed all of the properties, all the water contents from them and whatnot. Okay, what you're looking at is the inside of the actual cremation hearth itself. This is the chamber that the human remains are placed in, and this is where the main combustion chamber is. If you look at the top right-hand corner, you'll see an opening. Now that area leads into what they call an afterburner chamber. This is a typical retort design. Most crematoriums do not stray from this design very much, even from the 1930s model right through to today. So the modern crematory actually, in the hearth itself, hasn't changed. The only thing that's really changed is the control of the draft. The burners are different. In this one we're using natural gas. Some use oil. The older models, particularly in the 30s, they were fired by coal. Now, in this one, the human remains are exposed directly to flame. In the coal-fired model, the heat is usually radiated. In other words, the heat is from underneath the floor. The body's not exposed directly to the flame, but is just exposed to great temperatures, and it just combusts on that nature. They are quite a bit slower than these ones because of the nature that we're using gas-fired jets, and we can expose the body directly to the flame. You'll see the brick is flaking just over here at the side. You can see how fragile it is. I can just reach in and knock some of this down. Okay, that's normal spalling. Okay, the brick from the heat just begins to flake a little bit and a little bit, and that's the way the bricks wear out. Okay, once the brick is worn about halfway through, okay, about 2 inches in, then we have to re-brick the unit. Okay. Now, re-bricking the unit means you have to re-brick the whole thing. If you re-brick the sides, quite often you have to re-brick the ceiling. Sometimes in certain cases you may not if you're using an experienced bricker, but typically you're re-bricking the entire machine once you're bricking the side walls. Okay, now in a situation where these units are going to go over a major overhaul and repair, it requires a complete shutdown, usually up to 3 days of cooling, okay, before someone can actually go in there and work, because this floor, being several feet thick, will still radiate quite a bit of heat, even after 3 days. Okay, it gets quite hot in there. Now, in a case where we're tearing out, this unit is fairly simple. The ones that I've seen in the blueprints for Birkenau, they had 5 units of 3 hearth or 3 retorts. Okay, so these are, if you would picture this as being the center one, these 2 walls would be sharing the units next to it. Okay, it would be impossible to brick just one in a situation like that. You'd have to tear out all 3 since they're all connected and sharing these inner walls. Okay, that's quite a big job. This unit takes about a good 3 to 4 days to brick, just one unit. Okay, to tear it out and replace the bricks, and then you have a good day to 2 days of a break-in period. Okay. In the case of Birkenau, one of the major problems there, as I mentioned, you'd have to re-brick 3 of them all at the same time, but where a real problem comes in is where all of the units share one stack or one chimney. So in a situation like that, you'd have to shut down all of the units, because you can't operate units even though they don't need rebricking, because the heat would radiate in from the stack. You'd create a draft in this direction, and it just wouldn't be safe to rebrick it. So it poses a real problem, because you have to rebrick after, well, just say the floor you have to replace after 1,000 cremations. If you could even stretch that to 2,000, as the modern units are today, you can see the logistics of the problems that you're going to have immediately with that. There are just certain limitations that the refractory does have. Well, if you could imagine an average 8-hour day, it's possible to do about 3 cremations in that period of time. Extending that over to a 24-hour period, the maximum would be 9 to 10 bodies per day. Okay? Taking 2,000 and dividing it by 10 would be 200 units. Okay? And even if you did 2 skinny persons, as you mentioned earlier, per burn is still at 100 units. You know, just to do that, just to give you an idea. Okay. Some statistics, and I'll try to send along copies of this to you. Just in North America, that's Canada and the United States combined, last year, 412,457 cases. Just 400,000 bodies were cremated last year in North America. And to do that over the entire year, they used 1,064 crematories to do that. Okay? Just to show you just how many units realistically it requires to handle the demand in North America. No, that's impossible. If there's any stench, it will not come from human remains.
Well, probably you've answered the question, what about the stories from the Auschwitz survivors and Holocaust survivors that claim that one body was cremated every minute and a half in a 24-hour period?
Well, there's no technical support for that claim. Okay? There never was. There's a lot of witnesses that claim to be so, and you know, they can throw figures, but there's no proof, okay, that's been produced to me yet that shows that it's possible to cremate at that rate. Okay, the technology, as far as I'm concerned, does not exist up to date, even with using gas burners. I don't think it'd be really possible to do so.
But would there be any difference in the time element between a skinny body and a fat body?
No. The fat body contains the fat or oils. Oils is another fuel, okay, and will burn. Okay, so if you put charge the retort area with an obese person, the fats will contribute to the cremation itself. Okay, to speed that process up. But if you think of the skinny person, they don't have that extra fat, so they don't have that extra fuel, so the temperatures don't reach as high. Okay? So the unit runs hotter with an obese person than with an emaciated person.
Okay, what is your opinion of the claims of the Holocaust survivors in court testimony under oath? And I don't know if you were there or not, but one of the witnesses claimed that they could tell on every day what type of people were being cremated because the smoke was a different color for different ethnic groups.
Well, that has no fact basis to it at all. You know, I find it quite a bit of an exaggeration. Again, you know, like the victims exaggerate the stories and they try to make them as emotional as possible. And in a way, I feel for it, you know, in one sense, but it has no fact basis to it. It's just simply you cannot tell by the color of smoke or flame or anything of that nature what race, color, or creed you may be. I think any average man can figure that one out on his own. You don't need to be a scientist to see that that's just an exaggeration.